All right, this is the other part of the fundamental theorem of calculus. So depending on what textbook you're looking at or who you're talking to, they could call it the first or the second fundamental theorem of calculus, or part 1 or part 2. So I'm just going to call this the other portion of it. So fundamental theorem of calculus. I'll say we're continued because we're continuing this from the other notes that we had. So it says if the function g of x is defined as the integral from a to x of f of t dt, then g prime of x is f of x. So g of x is defined as this interval. Then the derivative of this is f of x. Or an alternate form is d dx, because that's what it says. That's how we say find the derivative of an expression instead of find the derivative of an equation. D dx of the integral from a to x of f of t dt is f of x. So the first thing we want to look at is just how does it work? So I'm going to go ahead and write that first. How does this work? So I'm going to start off by saying that g of x is defined as that integral from a to x of f of t dt. And this is just referring to that original fundamental theorem of calculus that we already looked at. And this is our function, so we're going to take the antiderivative of that function, which is capital F of t. And we're going to evaluate that antiderivative from a to x. So if we do that, then g of x gives us f of x minus f of a. So capital F of x minus f of a. So that's the antiderivative evaluated at x and evaluated at a. So then if we go through and we take the derivative, then we would say g prime of x is the derivative of this function, which is capital F prime of x. And whenever we do that, we always multiply by the derivative of the inside. So we're doing the chain rule here, times x prime minus f prime of a times a prime. And a right here is representing a constant, some sort of number. So that means that the derivative of a would always be 0. So it's the derivative of a constant, so it equals 0, which makes this part go away. And so we have g prime of x equals the antiderivative evaluated at x times x prime, which we're saying is f of x. Okay. So we're going to go ahead and, because the derivative of x prime was just 1, right? Or derivative of x is just 1. So this is us saying that I'm literally plugging x in. I just want to make sure that makes sense. So see how I had f of t, and now I'm just ending up with f of x. So we'll practice this. I think that the definition is one of those where we might revisit where the definition of it comes from later. But the examples, you'll start to pick up on the pattern for those. So, and there's 2 different ways the examples can be written, or problems can be asked to be done with this. And so I'm going to kind of alternate back and forth so you can see both versions. So if we have g of x equals the integral from 0 to x of 1 over t squared plus 1 dt, and they want you to find g prime of x, then what we're going to do is we're going to say that g prime of x equals this function 1 over x squared plus 1 times the derivative of x is just 1 minus 1 over 0 squared plus 1 times the derivative of 0 is 0. And what happens is this part zeroes out, it goes away. And so we have g prime of x equals 1 over x squared plus 1. Okay, here's our next example. We're going to say that g of x is the integral from 0 to 2x of 1 over t squared plus 1. We're going to do a few of these just so you guys can see how the problems would differ from each other and how similar they are. So g prime of x, is 1 over 2x squared plus 1 times the derivative of 2x is 2 minus 1 over 0 squared plus 1 times the derivative of 0 is 0. So you can see that really what I've been using is this part right here. So that cancels, that's just nothing because it's zeroed out. And then we say g prime of x equals 2, right, because this 2, I moved it to the top. 2x squared, 2 squared is 4, so 4x squared plus 1. And that's our derivative. And then I think I only have one more of these. Nope. Okay. 2 more using the same function. So this one, we have g of x is from 0 to x squared for the same function. And we're going to say that g prime of x is 1 over x squared squared plus 1 times the derivative of x squared is 2x minus 1 over 0 squared plus 1 times the derivative of 0. And again, that's nothing. And so I'm going to move that 2x to the top. So we have 2x over x squared being squared is x to the 4th plus 1. All right, so see how similar those were. The number, anytime you evaluated the constant, that part was gone at the end. It didn't matter that it was 0, it still would have been gone if it was a number 1 or a number 5 or whatever. Okay, we're going to do one more like this before we start to work with a different function. So this one says, if g of x equals the integral from x to x squared, so we mixed it up a little bit this time. Then g prime of x is going to be 1 over x squared squared plus 1. And the derivative of x squared is 2x. Minus 1 over x squared plus 1. And the derivative of x is 1. So notice I'm not multiplying by the derivative of the whole thing. I'm multiplying by the derivative of what I've been plugging in. That's the chain rule part of it, is I'm multiplying by the derivative of the inside. And the inside is what I've been plugging in. So that means that my g prime of x is 2x over x to the 4th plus 1 minus 1 over x squared plus 1. And I think at this point we can kind of leave stuff here. You know that if you needed to, if this was like a multiple choice problem and that was not one of your multiple choice answers, then you would probably need to get a common denominator and figure out if that was, if you'd gotten it right and it just looked different. Okay, so now we're going to try a different type of problem, and I'm going to show the notation a little bit differently. So I'm going to say that this time we're going to evaluate d dx of the integral from x to 1 of t squared, the square root of t squared plus 1 dt. Okay, So this is just going to be, I'm not going to say g prime of x or anything because it's just an expression and I'm evaluating it. So I'm going to go ahead and just plug the 1 in. 1 squared plus 1 times the derivative of 1 is 0 minus x squared plus 1 times the derivative of x is 1. And so that zeroes out, and we just get negative square root of x squared plus 1. And it's not that a function equals that, it's just the derivative of this expression happens to be this other expression. Okay, let's do another. So the derivative of the integral from x to 2x of 1 over t dt is going to be 1 over 2x times the derivative of 2x is 2 minus 1 over x times the derivative of x is 1. So the 2's cancel, times 2 and divide by 2. So we have 1 over x minus 1 over x equals 0. Okay, and I'm going to do one more, I think. How many did I have? A few more, but I can do this tomorrow. Okay, so one more. We're going to do d dx. So take the derivative of the integral from pi to x squared of sine t over t dt. And so that would be sine of x squared over x squared times the derivative of x squared, which is 2x, minus sine of pi over pi times the derivative of pi, which is 0. Since pi represents a number, its derivative is 0. So that's nothing. I have an x up here, which can cancel with one of those x's down there. And so that's going to leave me with sine of x squared over x. Oh, and I still have the 2. 2 sine of x squared over x.